So we're going to work a few more problems in preparation for the 3.1 to 3.5 test. So see if we can kind of see what's going on here a little bit. We have h of x is equal to x raised to the e to the third power plus pi to the fifth raised to the x power plus 3e to the x squared. So what we want to see for the x e to the third, we want to see that as just x raised to a power. So e to the third, although it's a strange number, is still just a number. So we're going to use our power rule and bring the exponent in front times x to the exponent minus 1. So there's the derivative of the x e to the third. Now the second one, that pi to the fifth to the x, we want to think of as differentiating a to the x, where the a is this kind of strange pi to the fifth. And remember, that's going to be the same exponential times the natural log of the base. So that's going to make this be the same exponential. So we'll get another pi to the fifth raised to the x, and then times the natural log of pi to the fifth, which you're welcome to leave like that, or if you are looking for an opportunity to flaunt your knowledge of logarithms and exponents, you could say that pi to the fifth to the x is pi to the, I lost my pen here, is, okay, pi to the 5x, and then you could bring the 5 in front of that natural log and call that 5 natural log of pi, but that's just for the adventurous among us. On the next one, the 3e is just the coefficient, that's just a number, so we're really just differentiating x squared, so the 2 is going to come down and multiply the 3e to make it 6e, and then x to the first, and so there is our derivative. Now the second one, on our yellow one, we're going to find the slope of y equals e to the 3x minus 1, where the graph crosses the x-axis. There's kind of a problem within a problem here. We want to find the slope, so ultimately we're going to find the derivative. And the place we want to evaluate the derivative is the place where this crosses the x-axis. So remember, any curve crosses the x-axis when the y is equal to 0. So to find that place where it crosses the x-axis, we're going to put in 0 where the y is and then solve for the x. So we can take the natural log of both sides and get, that's going to be 3x, and since the natural log of 1 is 0, then we're going to get x equals 0. Kind of disappointing, but that's the answer. Now we need our slope, so we need the derivative. So our derivative is going to be the derivative of e to the 3x, which is a chain rule derivative. So that's going to be e to the u times the derivative of the exponent, the du, which is 3, and then the derivative of negative 1 is just 0. And now we know we want to evaluate that at x equals 0, and so since e to the 0 is 1, that's going to be 3. So the slope of the line of the tangent or the curve at that point is going to be 3. That's the next panel. And so now we want to know for what values of x is y equals e to the x squared concave up. So remember, concavity has to do with the second derivative. So this question is really asking us, where is the second derivative positive? So to answer that question, we're going to have to first find the first derivative and then differentiate that to get the second derivative. So this is a chain rule derivative because you have e to the u, so you're going to get e to the u, that same exponential back, times du, the derivative of the exponent, which is 2x. So there was our first derivative. Continuing, we're going to take the second derivative, which is now going to involve a product rule as well as a chain rule. So we have the first 2x times the derivative of the second, e to the x squared, which we said was 2x e to the x squared, plus the second, e to the x squared, times the derivative of the first, which is 2. And we want to know first where is this 0 so that we can then figure out where is it positive. So let's factor out a 2e to the x squared, and that will leave behind, I believe, a 2x squared plus 1. So our exponential, 2e to the x squared, is always positive, never 0. So the only place where this can be 0 is going to be where 2x squared plus 1 is equal to 0. But that means we're going to end up trying to take the square root of a negative, which we know doesn't work. So that is, there is no place that the second derivative is equal to 0. That means it never changes sign. So that means it will always be whatever sign it is. And because we know that this is always positive, an exponential lies above the x-axis, anything squared is always positive, so that means that's positive. So f double prime of x is always positive. And so, therefore, it is going to always be concave up for all real numbers.